Consider our kinematic variables. We've got time, we've got position. I'll just do x, just consider one coordinate of position, velocity, and acceleration. And so we've discussed how they're related, and we'll get into more detail about the specific relationships in equation forms. But let's talk about when these are positive or negative. Okay, now that's an important question. We often will get things mixed up by just thinking, oh, it's positive or negative. For example, let's take acceleration. When I say acceleration, what comes to your mind? You might think speeding up, okay, and you might think that's a positive acceleration. Okay, let's do an example. Let's say that a car, and here's my car just as a block, it's moving this way and speeds up, so its vectors get bigger, its velocity vectors get bigger as it's going along in that direction. So how would I draw the acceleration vector? Well, the change in velocity is this way. It's getting bigger this way, which means my acceleration ought to be that way during this time. Okay, so is that positive? You might want to say it's positive, but it depends. The critical thing about positive and negative depends on your coordinate system. If I choose a coordinate system such that positive x is that way, then all of these variables are positive. Okay? Now that's generally to the right is our conventional positive direction, and so if no coordinate system is implied, then you can assume that to the right is positive and upward would be positive for the y component. But we need to be more specific. So for example, let's consider position. The position here is 0. It's neither positive nor negative. The position here is positive because it's in this positive region. Okay, let's do a different example. Let's have a car that's going this way, and it speeds up, and then it quickly slows down, stops, and starts going the other way. Okay? So we have two regions of acceleration here. The acceleration in this region is pointing to the right again. Let me get my velocity vectors labeled here. So in this region, the acceleration is to the right because these vectors are getting longer. It's speeding up that way. So the acceleration is that way, to the right. And even though over here it's in the negative area, all of those are pointing to the right, which means they are all positive velocities and acceleration. What about this one? This acceleration is also positive, and it's slowing down, stopping, turning around, which means the acceleration is that way, to the left, is pointing to the left, because the acceleration vectors are getting smaller or more negative as we go. So the acceleration here is pointing to the left. Now the velocity here and here were positive, velocity is 0 there. This velocity, though it's in a positive region, it doesn't matter, it's what direction is it pointing. This velocity is pointing to the left, therefore it's a negative velocity. And this acceleration is pointing to the left, so it is a negative acceleration. Okay, but let's talk about position now. Over here, the position is negative because it's in the negative region. All the positions over here are positive. So you can have positive and negative accelerations, positive and negative velocities anywhere, but only where you define negative position can you have negative positions. Okay, that seems kind of obvious, but it can be kind of complicated when we try and compare all these things. So I'll have another example video of different coordinates.